Right, so we're going to have a look at covalent bonding. Before we do that, you need to be aware of the structure of the atom, and also you need to be aware of the fact that atoms want to get a full outer shell. Both those things clear, let's move on. So here I've got an atom of hydrogen. It's got one electron in its outer shell. In fact, it's got one electron in total, so its first shell is its outer shell, one electron in it. We're going to have a look at chlorine as well. And there's my chlorine atom, group 7, so it's got 7 electrons in its outer shell. And you'll notice that chlorine has got a gap here, it wants one electron. Hydrogen, because this shell here is its first shell, it can only fit 2 electrons in it, so it also wants an electron here. We could move this electron here, but then chlorine would end up with 6 electrons. We could move this electron here, and chlorine would end up with 8 electrons, but hydrogen would have no electrons. So the idea is this and this joined together in this way. There's my hydrogen atom, and here's my chlorine atom, and if we do this, you should be able to see that hydrogen here now has 2 electrons in its outer shell, first shell, full outer shell. Chlorine has now got 8 electrons in its outer shell, so we've got 2 atoms very happy. The reason that's happened is because these 2 electrons are being shared by hydrogen and chlorine. Let's take a look at another example. Let's take a look at oxygen. There's one atom of oxygen. It's got 6 electrons in its outer shell, and it needs 2 electrons to get a full outer shell. And here's another oxygen atom. So we've got a gap here for 2 electrons, we've got a gap here for 2 electrons. If we just move these 2 across here, this oxygen is happy, but this oxygen would only have 4 electrons. So this atom here needs to gain 2 electrons, this atom here also needs to gain 2 electrons. And if I'm very careful about how I draw this, let's draw it slightly differently. Let's put 2 electrons there. If I draw it with the 2 outer shells overlapped, we've got this oxygen atom here needing 2 electrons, and they've got to come from here. So I'm going to have 1, 2, 3, 4, 5, 6 electrons here. 4 of the right hand electrons remain the same, but these 2 electrons here, all they do is slide round, so they're sitting here, which means they're therefore being shared. This oxygen atom over here is happy, this one isn't. This one has still got 6 and it needs 2 more. It can only get those 2 more from this oxygen here. So let's just slide these around to here as well and see what happens. So the electrons that were there now go here. If you count them up, 1, 2, 3, 4, 5, 6, 7, 8. This oxygen is happy. 1, 2, 3, 4, 5, 6, 7, 8. This oxygen is happy. So again, we've got covalent bonding. In this example here, we've got a single bond between the hydrogen and the chlorine. Here, because we've got 2 electrons. Here, we've got 2 electrons here and 2 electrons here, which is a double bond between those 2. We can show that in this way. H, single bond Cl, O, O, double bond. Remember, one bond here, one bond is 2 electrons, 2 bonds is 4 electrons. The co bit, co in English means sharing, to share things between them, and the valent is the outer electron. So what we're doing is sharing the outer electrons. Hopefully that helps. It would be nice to do some examples now, so let's have a go at some examples. Example number 1 is chlorine, which goes around in pairs. Example number 2 is water, the formula of which is H2O. Example number 3 is going to be, let's do methane, and the formula of methane is CH4. And lastly, number 4, we'll do carbon dioxide. Carbon dioxide, and of course the formula of carbon dioxide is CO2. So what I'd like you to do now is pause the video, have a go at doing Cl2 first, then H2O, then methane, then carbon dioxide, and you can check your answers in a moment. So here's the answer for chlorine. What I've done, remember, is it's handy to have the electrons on different atoms shown differently. They look identical in real life, but I'm showing them differently here. 1, 2, 3, 4, 5, 6, 7 electrons here. 1, 2, 3, 4, 5, 6, 7 electrons here. We've got 2 electrons being shared here. So chlorine looks like this. Cl bond Cl. Make sure you have a go at water, and then we can check that in a moment. Okay, here's water. Hydrogen's got 1 electron. Hydrogen's got 1 electron. Oxygen's got 1, 2, 3, 4, 5, 6 electrons. We've got shared electrons here, meaning that hydrogen has got 2 electrons in its outer shell. Hydrogen's got 2 electrons in its outer shell. Oxygen has got 2, 4, 6, 8 electrons in its outer shell. And water looks like that. Next example. There's methane, and again you should be able to see that carbon starts off with 4 crosses as its electrons. Each hydrogen starts off 4 circles as its electrons, and then we get a bonding pair here, pair here, pair here, pair here. Each of the hydrogens has got 2 electrons in its outer shell. Carbon's got 8 electrons. Everything's happy, and so we'd show the structure of methane as that. Lastly, carbon dioxide. Again, pause if you haven't done this as an example. Here's carbon dioxide. Carbon has got 4 crosses in its outer shell in group 4. Oxygen's got 6 circles. Oxygen's got 6 circles. We've got 4 electrons here, giving oxygen 1, 2, 3, 4, 5, 6, 7, 8. Oxygen here 1, 2, 3, 4, 5, 6, 7, 8. Carbon here 1, 2, 3, 4, 5, 6, 7, 8. Which means that my final compound is going to look like this, with a double bond here, 4 electrons, double bond here, 4 electrons. Hopefully that's helpful.